So, in this question, there is a body of mass 100 gram is moving in a circular path of radius 2 meter in a vertical plane as shown in the figure. The velocity of the body at point A is here. The velocity is given as 10 meter per second, not 100, 10 meter per second. What is the ratio of the kinetic energy at the point B and C? Apo here when it is starting, the total energy is nothing but kinetic energy. We can take this as a reference point where the potential energy is 0, height is 0. Apo when it is going here, what will happen? Your kinetic energy which is here, okay, which is here, should be equal to the total, that is actually total energy at A should be equal to total energy at B, because energy is conserved. So total energy at A is nothing but kinetic energy at A, which is equal to total energy at B is nothing but potential energy at B plus kinetic energy at B. This we can use. So at the point A, your kinetic energy will be equal to what? Simply half mv square. So half m, velocity is 10. So v square, if you put, you will get 100, half mv square. What will be the potential energy at the point B? We need to find what is this height. So here this is the radius r. Better I'll use different color. Okay, we can manage with this color itself. So either radius r, inga I want to find what is this height. About what we can do here, if you put sine or cos 60, cos 30, sorry, cos 30 degree is nothing but adjacent is nothing but this height. Okay, your adjacent by r, so your adjacent is nothing but r cos 30 is nothing but root 3 by 2. But this distance is root 3 by 2. Total distance I know, which is r. Then what will be this distance? That will be r minus r root 3 by 2. So this is what the height here. Okay, height here. Up here m g h is nothing but r minus r root 3 by 2. So plus kinetic energy at the B is nothing but half m velocity at B whole square. Okay, so we do not know what is the velocity at B square, so we can keep this as constant. Why? Because they are asking the ratio of the kinetic energies, so this we can keep it as kinetic energy at B. If we solve this, what we will get? So here kinetic energy at B, okay, this is nothing but here I will get 100 m by 2 minus mg into 2r minus r root 3 by 2. So here I think I can cancel all the m, okay, so that m will be eliminated. So better we can substitute what is velocity at B. So expand this kb, so half m vb square will be equal to 100 m minus mg 2r plus mg r root 3 whole divided by 2. So here 2 and 2 will get cancelled. If you take m can be cancelled. So velocity at B square will be equal to 100 minus g into 2 into r. Okay, so here g is 10. Okay, so 10 into 2 is 20. 20, radius is also 2. Yeah, 2. 2 into 2 is 4. So it is 40. Plus 10 into 2, 20. 20 root 3. So here we will get 60 plus 20 root 3. So this is what VB square. Okay, this we can keep it as it is. We can find what is the velocity at C using the same strategy. So if we use the same strategy, we need the height. Okay, we need the total height here. So here this is at a height of this. Over here if you see, this is radius, so r plus, we have to find what distance is this. If we find what distance is this, total distance is nothing but r plus this distance. Up here what I can do is, here this is 90 degree. Okay, so if I draw a line perpendicular to the vertical line, this should be 30 degree. Okay, because if this is 30, this is a line perpendicular to this, and this is a line perpendicular to this. About this is 30 degree. So here if I want to find the opposite, I can use sin theta. So here if I use sin theta, sin 30 degree is nothing but opposite by radius. Appo I will get opposite as r, sin 30 is 1 by 2. Appo r by 2. So this distance is what? R by 2. Appo total distance is r plus r by 2. Okay, appo same idea we have to use. Appo total energy at A should be equal to total energy at C. Total energy at A is nothing but half mv square. Velocity is 10, so 10 square 100. Total energy at C is nothing but potential energy plus kinetic energy. So potential energy is nothing but mg. Total height is what? R plus r by 2. Am I right? Yes, r plus r by 2 plus kinetic energy is nothing but half m velocity c square. So here we can find what is this vc square. M we can cancel in the initial stage itself. So and then I'll get 100 by 2, which is equal to here g is 10, radius is 2. So I think we can keep the 2 in common. So if you take LCM, you will get what? 3r by 2 plus vc square by 2. So we can cancel all these 2's. So 100, which is equal to 30 into radius is 2. So 30 into 2 is 60. So 60 plus vc square. So here your vc square comes out to be 40. So here the question is ratio of the kinetic energy B and C. So kinetic energy B and kinetic energy C. So this is nothing but half mvb square by half mvc square. Half m will get cancelled. Vb square by vc square. Vc is 40. So 60 plus 20 root 3. So we have to divide this. What we are getting? 60 plus 20 root 3 whole divided by 40. So here if you do zeros, we can cancel, and again if you cancel in two table, what you will get? 3 plus root 3 by 2. This is what I will get. So 3 plus root 3 by 2. So 3 plus root 3 by 2.